Hi, everyone, and thank you for joining me today for episode 763 of the People Behind the Science podcast. Today, we are excited to be resharing our conversation with Dr. Marcie O'Malley, originally released on July 16th of 2018. Listeners, the goal of Marcie's research is to use robotic systems to maximize what people can achieve. She's working on incorporating robotics to rehabilitate and restore function in people after spinal cord injury or stroke. To do this, Marcie creates wearable and interactive robots to assist with therapy. Another area of her research focuses on the use of robotics for training and surgical simulations. And in our conversation, Marcie shared fantastic stories from her life and her research. So I hope you enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to the People Behind the Science podcast. Today, I am delighted to introduce you to our guest researcher, Dr. Marcie O'Malley. So, Marcie, thanks so much for joining us on the show today. How are you?
I'm doing well. Thank you.
Wonderful. We are excited to learn more about you and your work during our conversation today. But first, I want to take a moment to give our listeners just a little bit of background. So listeners, Marcie is the Stanley C. Professor of Mechanical Engineering, as well as a Professor of Computer Science and Electrical and Computer Engineering at Rice University. Marcie is also an Adjunct Associate Professor in the Departments of Physical Medicine and Rehabilitation at Baylor College of Medicine, as well as the University of Texas Medical School at Houston. In addition, Marcie is Director of the Mechatronics and Haptic Interfaces Lab at Rice University, Director of Rehabilitation Engineering at TIRR-Memorial Hermann Hospital, and co-founder of Houston Medical Robotics. She received her bachelor's degree in mechanical engineering from Purdue University, and she was awarded her master's degree and Ph.D. in mechanical engineering from Vanderbilt University. Now, Marcie has received numerous awards and honors recognizing her teaching and her research throughout her career, including the George R. Brown Award for Superior Teaching at Rice University, an Office of Naval Research Young Investigator Award, and an NSF CAREER Award. She has also been named a Fellow of the American Society of Mechanical Engineers. And today, Marcie is joining us to talk about some of her experiences in life, science, and engineering. So Marcie, we want to learn more about you and more about your work as well. But we want to start by talking about life outside of science. So can you start by telling us how you like to spend your time when you're not very busy at work?
Well, I find that I don't have a lot of completely unstructured time these days. I'm a mom of twin boys who are 11 years old. So it's a lot of activities. School projects. Actually just helped my one son take his cardboard robot to school this morning.
Amazing.
That he built out of recycled materials for a project they're doing. We do sporting events, soccer and baseball and art classes. But when we do find some free time, we like to go enjoy the parks or museums here in Houston. And we really like to travel as well.
That is awesome. Do you have a favorite family vacation spot that you go to?
We like to try new things. So we don't really have like a repeat destination that we would go to. One of our favorite trips was when we got to tour around Southeast Asia. We went to Cambodia and Thailand and Singapore, but we've also enjoyed exploring Europe. I was really fortunate to spend a year's sabbatical in the United Kingdom. And from there, we were able to visit different cities on the weekends around Europe. And that was really fun.
Well, that is phenomenal. Great to hear a little bit about what occupies your time when you're not at work. But I do want to chat about your work next. I know you're working on some amazing projects in the lab, but how do you describe what you do to someone who's not familiar with this area of mechanical engineering and computer science and where it all comes together?
So I think what really drives me and the research that we do is my desire to maximize what we as humans can achieve using robotic systems. So I'm really most interested in how we can incorporate robotic devices, maybe they're wearable or robots that we touch and interact with, to maybe restore function or rehabilitation after an injury like stroke or spinal cord injury using robots to do the therapy, but also for training. You can imagine surgical simulators or even using wearable devices to augment our capabilities or communicate with others. So I like robots that we touch and feel and wear.
I love it. I imagine your work really captivates people's imaginations when you talk to them about it. It's almost science fiction, like in some of the stuff that we're now able to do. So what is the response that you get to people interested in your work?
One thing that I have to do a lot is rein in people's imagination and explain to them we're not quite to an Iron Man suit or what we see in the movies or in science fiction novels. But we really have made wonderful advances in robotics, especially in recent years. I think the public is just really excited about the potential for robotics. We're open to robots in our homes, sweeping our floors. We wear our smartwatches, so we're kind of used to technology in our lives now. And I think that's really opening up people's imaginations as to what might be possible down the road.
Absolutely. Well, Marcie, I look forward to chatting more about some of the projects you're working on as we go through our conversation today. But I do want to talk a little bit about motivation and inspiration next, because I think it can be hard some days to get out of bed and go into the lab when you've got so many other things on your plate that you're juggling. But is there a particular saying or a quote or maybe a force that really keeps you moving?
I don't remember the details of the quote, but it has stuck with me, this idea that if you wait for it to feel like it's the right time to do something or try something, it's probably too late. So what kind of drives me is just an initiative to take a risk, to try something. And if it doesn't work exactly like you envision, you learn a lot from that. So I try in my own life be experimental and not huge risk taking, but to take those little risks that maybe you feel like only 90% qualified to do. And I also try and encourage that with my students, that if you wait until you think everything is perfect and aligned and ready to go, you probably have missed the boat.
Well, I love this point that you make, because I'm a victim of this myself. I think I never quite feel ready, but at some point you really just have to jump in and do it.
That's right.
Well, phenomenal to hear a little bit about what motivates you, but I'm curious to hear about some of the people who might have motivated or inspired you. I think as scientists, you meet so many wonderful people along the path of your career. Are there any that really stick out in your mind as mentors or role models or maybe early figures that really inspired you?
I think kind of coming through university and schooling, there were teachers early on in high school who encouraged me and pointed me in the direction of engineering and encouraged me to explore sort of newly developing fields like biomedical engineering, which was very new when I was entering college. But also, I think I get a lot of inspiration from my peers. And one person I'd like to give a little shout out to is Professor Allison Okamura. She's at Stanford University, and we met when we were both graduate students, and she's just about a little bit ahead of me career path. And I've always looked to her she has fantastic ideas. I think she's got good balance in her work and personal life. I think she also knows how to work hard, but have fun. And that's a theme that resonates with the people that I look up to. A good work ethic, creative, but also very happy to kick back and have a good time.
Definitely. And I think this work-life balance is something that a lot of people are struggling with, or sort of struggling with the idea of how on earth to manage it when you have so much to do. Do you have any tips or things that really work well for you in maintaining or establishing this balance?
I think balance is a difficult thing to actually achieve. I'm a dual career family, so my husband also has a career. So we just work out who can help with what area on any given day. He's the cook in the family. I tend to be the shuttler to activities, being in academia, having a little bit more flexible schedule. And we just sort of do the best in any given week. One week might be heavy with work and one week might be more heavy with family responsibilities. So I think you have to sort of look for balance on the grand scale and not necessarily on any given day. I don't really feel like I achieve any balance.
Sure.
But maybe holistically, we're able to do that.
I like it. And I've never thought about it that way, kind of looking on a larger time scale to make sure that you're maintaining balance, not kind of taking it in the hour by hour or day by day moment. So that's awesome advice. I like it. And we talked a little bit about some of these people who inspired you, but I do want to hear about where your scientific interests began. So Marcie, can you take us all the way back to the beginning and tell us what first sparked your curiosity in the worlds of engineering and science?
Well, my father can make anything out of hangers and duct tape.
Oh, wow.
And was always tinkering in the garage. And I was the youngest. So as the older kids were out of the house, I was the assistant. I would hold the wrench and you're going to learn how to change oil in a car. So I was always seeing him sort of tinkering and working. He very much worked with his hands a lot, build things and do remodeling projects. So I was exposed to that a lot early on. And then through school, as I mentioned earlier, I had a few high school teachers who suggested, because of my interest in math and science, that I might be a good fit for majoring in engineering. We didn't have any engineers in my family. Most of the people in my family are teachers. My mother was a high school teacher. My father was in education as well. So I had to do a little exploring to understand what engineering was all about. But I remember vividly, I did a project in high school, and I don't know if it was for an anatomy and physiology course or for a physics course. I can't quite remember the context, but the project was studying a mechanical frame that was designed and actually screwed into bones for individuals who were born short of stature or with different physical disabilities. And by turning screws in this frame, you could put loads on the bone and induce cell growth. So new bone cells would grow. And they could actually lengthen the bone by applying loads with this frame. And it looked like this medieval torture device.
Right.
But I was just fascinated with this idea that we could build mechanical things that would improve the human condition. So I didn't really kind of put it all together at the time, but actually when I got farther on in college, so I majored in mechanical engineering because I felt that that would give me a lot of flexibility as I figured out what interested me the most. I had the opportunity to do undergraduate research when I was at Purdue in a lab that was testing artificial knee implants. So they had a robotic device that you could insert this artificial knee implant. I worked with Professor Ben Hilberry at Purdue University and learned about sort of the research process and how you design and test and iterate to improve your medical devices. Got to know some of the graduate students in that lab who encouraged me to think about graduate school myself. So I thought, well, I can apply to graduate school. I didn't really know what was ahead of me. But as I toured and learned a little bit more about getting an advanced degree and the opportunities that that would provide for me, I was really hooked. So I found a lab at Vanderbilt working with Professor Michael Goldfarb. He was a pretty brand new assistant professor at the time, and I was one of his first Ph.D. students. So I got to see the process of building a research lab at a university, developing your own research mission and program and training graduate students, and just the flexibility that faculty members have to decide their research direction. We joke that we can work on any project that we can convince somebody else to pay for.
Right.
So we need resources to do our research, and you have to come up with important problems that need solving, and you need to convince others that your approach is the right one. And I just liked the independence and flexibility of that environment while also still having this teaching aspect. I mentioned that I have educators in my family. So I think part of that was really appealing to me about being a professor as well, that I could have this research side of my job, but I could also teach undergraduate and graduate students. And that certainly keeps you on your toes and keeps you connected to the youth.
Absolutely. Well, I think it's wonderful that you're able to incorporate both the teaching and the research in the career that you have today. And I'm curious to hear, though, what kind of next direction did you take after you got your PhD in mechanical engineering? What then brought you to this cool area of robotics where you are at Rice?
I mentioned the research I had done as an undergraduate at Purdue, where we were in a lab that was designing and testing these knee implants. So again, it was mechanical engineers designing devices that would improve walking and mobility. In my graduate work, I was a little bit more on the virtual reality and robotics side of things. We were interested in how you could create these touch interactions with a virtual environment and how good the hardware needed to be. So if I tell the story of my PhD was about the refresh rate on your computer monitor needs to be at least 30 hertz before your eyes don't notice that the image is refreshing. And we were interested in sort of what's the same equivalent thing for touch. How fast do we need to refresh the forces? How much force do you need to feel for you to think that you're touching these rigid objects? Mm-hmm. When I got to Rice, I was very fortunate to get a faculty position straight out from my PhD. I ended up in Houston. I'd had some previous interactions with NASA through Marshall Space Flight Center during my graduate work. And here I had this fantastic robotics lab at Johnson Space Center in Houston. And I had some initial interactions with those folks who were developing a humanoid robot that is what's called teleoperated. So imagine like a remote control. But the remote control for this robot is not just a bunch of joysticks, but you actually put a virtual reality headset on and sensors on your body. So the robot tracks the movements that you make. And they wanted to restore touch to the operator so that the operator could feel what the robot was feeling. So that was sort of the first applications that we worked on when I got to Houston. But across the street from Rice is this amazing medical center. So the Texas Medical Center is the largest medical center in the world, employs over 100,000 people, and there's 40 plus institutions there, different hospitals and medical schools, Veterans Affairs, children's hospitals, rehabilitation hospitals. It's a playground and just a fantastic resource for the city. And I started thinking about how the work that I had done in the past, maybe coming back to where I started from, like that first inkling of that frame that could stretch bones or these knee implants that could improve mobility. How can I take robotics and find interesting applications in medicine? And that's when we really started moving in the direction of rehabilitation with robotics and also robotic systems for surgical environments.
Gotcha. Well, Marcie, this sounds like a wonderful scientific and engineering journey that you've had here. And I'm curious, though, because you've made it sound so easy, so wonderful, like one thing just naturally flowed to the other. I think not a lot of people share the stories of the challenges, the frustrations, and the struggles, but I think those are so important to get out there. So everyone kind of has a realistic picture of what life and the career of a scientist looks like. So do you have a struggle or a challenge that you can share with us today and maybe talk a little bit about how you worked through it?
I think it's very true. You look at accomplished scientists and researchers, and it just looks like they were meant to be where they are now. Mm-hmm. And I think it's very easy for me to look backwards on my path and see the very natural progression of experiences and choices and opportunities that I had that got me to where I am now. But if I rewind and think about at each fork in the road, I didn't know what was the best choice. I'm not sure I necessarily optimized my path. But I think the best we can do is, given any decision point, what is the opportunity that makes the most sense for you at that instant in time? And those reasons can be scientific and they can be personal too. Certainly what attracted us to Houston was an opportunity for both my husband and I to have successful careers. So I think you just have to get to each point and make the best decision that you can make at that time. And then you sort of can look back and say, oh, of course, it's all so obvious.
Right. You build the story after, yeah.
But certainly it is not easy. And I think research takes persistence. And I think you need creativity, you need good ideas, you need hard work, but the persistence is really what's going to get you through. The pile of rejected proposals and ideas that didn't work is so much larger than the pile of things that have been funded or research that has produced fantastic results. And I find that having these different aspects to my career is what gets me through. So maybe it's that we're trying to push in a new direction of research and we're just not able to convince a federal agency like NSF or NIH to fund that work, and it gets rejected and you rewrite it and you submit it again and it gets rejected again. But maybe at the same time, you have a student who's finishing their degree and seeing all the opportunities that they have as they move on in their own career path. So you can sort of step back and say, well, maybe I'm not having success in this one area, but I have this success in this other area. So with all the different plates we have spinning, be it successes in our teaching, successes in our research, or in service, there's setbacks in all of those as well. But maybe on the whole, we find that we can persist.
Absolutely. Well, it's been great to hear a little bit about your career path and some of these challenges and struggles. And I think you're absolutely right. Looking back, hindsight, you're like, oh yeah, clearly it makes sense because you sort of build this story afterwards of what happened and make the connections of how you got there. But I think it's so helpful for our listeners out there to hear that they don't have to have it all figured out ahead of time. And you don't even have to make the quote unquote right decision all the time to end up in a great position. So I think that's wonderful to share with our listeners. And one thing that I am curious about that we didn't mention in kind of covering your career path is where this company fits in. We mentioned in our introduction here that you're also co-founder of Houston Medical Robotics. So can you tell us where that fits into the picture?
It's funny that you bring that up right after the discussion of failures. This was a really interesting experience. So I had, through my trying to develop research directions in surgical robotics, come to meet a really fantastic individual named Dr. Billy Cohn. Billy is a cardiothoracic surgeon in the Texas Medical Center, and some would call him a serial entrepreneur. Mm-hmm. So he has sort of an engineering mindset, but he's a surgeon, and he is constantly coming up with ideas for new medical devices. He has hundreds of patents and companies. And he was approached by another doctor and a nurse who worked in critical care about a particular problem with accessing the subclavian vein in the neck. So when individuals have really difficult medical conditions and they're in intensive care, they often need to deliver large quantities of medication at the same time. So they put in what's called a central line, which is basically like a big IV port, but they do it in this large vein under the collarbone. But it's really difficult to access this vein. And Dr. Cohn and Dr. Hurley and the others on the team had some ideas about how to do this, and they wanted to do some advanced sensing and actuation, maybe like a robotic device. And Dr. Cohn said, we need to get Marcie from Rice. Mm-hmm. So they approached me and really brought me on board with this idea and this process. So we went through patenting the idea and prototyping the idea, and then got some investment from outside and got to the point where none of this were going to make this our day job. We all were kind of doing this on the side. So we hired a CEO. And at that point, we really sort of learned life lessons, which is when you decide it's not going to be your day job, you have to let go of the control a little bit. And I think the leadership of the company that we put in place took a direction a little differently than maybe we envisioned. So it's been a good experience to have a startup company. We don't have a commercial product, but I learned a lot about how you go from conceiving an idea to patenting to prototyping to pitching and getting investment to develop a product. And maybe from those lessons learned, if I try this again, we'll be a little more successful next time.
Definitely. Well, Marcie, this is wonderful. And I'm so glad that you shared this story. And I'm curious, did you ever consider yourself as an entrepreneur or maybe kind of getting into this world of the startup scene before being approached by this doctor?
I actually hadn't. And part of it was just there's only so many hours in the day and we have to make choices about what we do and what we don't do. When they approached me, I think it was shortly after my twins were born. And I was able to carve out some time to try and explore early on. But I knew that my heart was at the university. I had a growing family and I had my own research program, and I just wasn't going to be able to do everything. So entrepreneurial efforts have not been something that I personally have wanted to pursue. I'm much more interested in answering the scientific questions, publishing papers, getting the knowledge out there. And if others want to take those ideas and come up with their own products and companies, then I think that that's where I'll find satisfaction.
Gotcha. Well, I know you have quite a bit on your plate, even just with the research that's going on in your lab, so it's completely understandable. But I would love to chat about some of this research. So is there a project that you have ongoing right now that you are just so excited about that you want to tell us all more about?
I do have one that's been really fun and a long-term collaboration. So I mentioned that we were trying to work in the area of surgical robotics. We had found from our work in rehabilitation that not only could we use these robotic devices to deliver therapy, but we could also use these robotic devices to assess the recovery of individuals with stroke and spinal cord injury. So these robots, not only do they have motors that can move you around and deliver that therapy, they also have sensors that can track your movements. And we had noticed with our stroke subjects that we could see changes in the characteristics of their movements that we could record with our robotic devices. And I was talking with some surgeons about this, and we kind of started brainstorming, well, maybe we could do this with surgical skill. Maybe we'd see the same thing when novices start to learn how to do different surgical procedures. Maybe their movements and characteristics would change. And this was really exciting because in both the rehabilitation domain and in the surgical skills and training domain, there's not a lot of good objective measures to assess people. In rehabilitation, they might do 5 weeks of therapy and they might evaluate you when you start and then when you finish. It's very coarse. Can you do this task or can you not do this task or can you sort of do this task? And that's basically how they come up with their rating scales. Mm-hmm. And what we had with our robotic device was these very quantitative and objective ways of capturing movement quality, movement efficiency. And we had this idea that maybe we could use this for surgery. And what was really fun about this collaboration when it was starting out was both myself and the physician I was working with, Dr. John Bismuth at Methodist in Houston, we didn't have a ton of resources, but we really believed in this idea. So he was able to recruit a researcher on the clinical side, and I was able to recruit a student on the engineering side. And we collected a lot of data, and we were able to show that indeed, when endovascular surgeons are navigating, they're using these flexible guide wires and catheters that they're inserting into an artery that they access through the hip area. Imagine pushing a string through a straw. That's right. Effectively what this surgery procedure is like. That you can clearly see that the way they control these flexible guide wires and catheters changes distinctly over time, and you can quantify it with the same kinds of metrics we were using for rehabilitation.
Interesting.
That was really exciting, and we were sort of doing this. We were bootstrapping resources and working on weekends and collecting data when we could get it. and it bore out, right? So our hypothesis that we could have these quantitative measures of surgical skill worked. What's really exciting is that now we say, well, we know that your movements are smoother. That means you're more like an expert. It's a very logical thing, but wouldn't we want to provide feedback when they're training? Just like if you're playing video games, you get a score. If you're taking a sports lesson, you have a coach telling you what you need to do. If it's tennis, you need to adjust your swing or turn your wrists or change your hips or whatever it is. You're getting that feedback while you're practicing. And we wanted to take these metrics and see if we could figure out a way to provide feedback during training. So these endovascular surgeons do a lot of practice procedures on plastic models or on virtual reality simulators. And we're able to track those tool movements, compute these metrics. And what we're doing is we're providing feedback to the trainee through vibration cues. So we can put a little disc-shaped actuator in an armband on their upper arm, and we can provide vibration that tells them about the smoothness and efficiency of their movements. And we're finding that they're really changing their strategies in the way that they do these procedures based on the feedback that they're getting. So it's this long vision that we've had that started way back in 2012, 2013. We're now seeing coming to fruition. And this coming year, we're going to be not testing in our little laboratory experiment, but actually shifting over and testing our methods on surgical trainees on these virtual reality and robotic platforms. And it's been a really exciting journey. It's fun collaborators to work with. And not only have I been able to work with Dr. Bismuth at Methodist, but another colleague at Rice, Dr. Mike Byrne, who's an expert in human-computer interaction. And I think science is the most fun when you collaborate and when you bring ideas from these sort of different fields and different perspectives together. And that's when you really can accelerate your progress. And that's what this is. We've got a surgeon, we've got an expert in human-computer interaction, and myself in haptics and robotics. And we're really rocking and rolling now, and it's been a fun project.
Well, this sounds like an amazing collaborative project, Marcie. And you mentioned that you're incorporating this now into the surgical training realm. So is the goal to improve the quality of training, but also to reduce the training time? And if so, do you have ideas of maybe how much you'll be able to compress that?
I think those are both goals. And also, as new surgical techniques become available, you have experienced surgeons who want to learn the new procedure. They want to learn the minimally invasive procedure or to use the new technology. So they could come for a training workshop and you would be able to determine whether they had improved sufficiently to go back to their own operating room and carry out that procedure. I think it's going to depend on what the particular specialty is, but we are seeing definite changes in the sort of learning rates and overall quality of task performance. So I don't think we're going to see tenfold improvements, but I think we can certainly know and be able to track objectively how these future surgeons are progressing with their skills.
Absolutely. And I think that has huge potential impact on the quality of medical care, because I think everyone dreads being a surgeon's first surgery. But if they've had a lot of these training experiences and they're already operating as an expert surgeon would, I think that would allay a lot of fears. So
absolutely.
Well, great to hear about this project. And it sounds like this has been a great success so far. But Marcie, I'd love to share another story of one of your successes in science, whether it was a big victory or just a small win that was really enjoyable for you.
So we've been working for a while in the area of robotic rehabilitation, and we developed these, we call them exoskeleton robots, because you kind of put your arm through a sleeve of a robot and that robot can assist you with your movements. And then we really see these devices as tools for therapists, sort of increase the kinds of interactions and the ways that they can help their patients recover from stroke or spinal cord injury. Mm-hmm. We were working with a young man who had been in a motocross accident, was in his early 20s, had an incomplete spinal cord injury, and he had some mobility and some independent movement of his hands, but he relied a lot on his family with just everyday tasks, from getting dressed, brushing his teeth, eating. So we brought him in to do one of our protocols. We typically would have somebody come and do 10 different training sessions over a span of a few weeks. And we were working on his forearm pronation, supination, so kind of the twisting of your arms, and we were working on his wrist movements. And when we analyzed all the data, we could see that he had some improvements. They were modest, but in the right direction. And I think we were feeling good that it was working, but I guess I was hoping that robotics would have a bigger impact on their recovery. Mm-hmm. He came back in for an assessment, and we got to talking, and it turns out that Randy really liked to play poker with his friends. And he was so excited because after doing our protocol, he was able to turn cards over by himself and manipulate his chips to do betting. So I was really pleased that I could help him get back into his gambling habits.
Sure.
But I think what it did for me was really put things in perspective. As an engineer, I'm a quantitative person, and I like to see that we go from point A to point B, and it's statistically significant and impactful when you look at the numbers. And what I have to remember sometimes, especially in rehabilitation, is that just because it's not a big quantifiable change doesn't mean that it's not a big impact in somebody's life. And it's just helped to keep things in perspective for me that some gain in independence that these individuals get doing robotic rehabilitation can have a huge impact on them personally if it means one less thing that a family member has to do for them. So I can't publish this,
right.
But I can certainly use this kind of feedback to keep me grounded in terms of what's really important about the work that we're doing.
Absolutely. And I think these clinical collaborations help inform the science then, because you start thinking about, okay, what sort of outcomes can we provide that might be most important to a particular patient or a group of patients? So I think you maybe get feedback both ways.
Absolutely.
Well, wonderful to hear about this project. And we've talked about a variety of different successes and failures and struggles in the path that you've taken to your career in science. But I do want to jump outside the scientific and engineering realm for a moment to talk a little bit about books. I love getting book recommendations from everyone that we've had on our show. So, Marcie, do you have a book that you've read, whether it is a scientific or engineering book or not, that you want to recommend to me and our listeners today?
I'll give two recommendations, and maybe one a lot of your listeners have already read. It was just recently became a movie, but I loved Ready Player One. I thought it was just fun, and I liked the integration of haptics into the story, that they have their suit and they can feel all these interactions that they're having in the Oasis. Not quite the same on the big screen as it was in the book. I would highly recommend the book instead, but just a fun read and a good reflection of the kinds of technology that interest me in my research. The other books that I've really been enjoying lately, I had a sabbatical in the UK in 2015 and 2016. We were living in the northeast of Scotland, and it's a sparsely populated area. And what we would do on the weekends is go on hikes and walks. They like to do hill walking. But we could wake up on a Saturday, so my husband and my kids and I, and say, well, what do we want to do today? Do we want to go walk on the beach? Do we want to go climb a hill? Do we want to go through some woods? Do we want to go see a wrecked castle? Mm-hmm. Each weekend we would have one of these adventures. And I just found some real beauty in the desolation of some parts of the north of Scotland. Our last summer there, we went to the Outer Hebrides, which are very, very sparsely populated islands in the Atlantic on the west coast of Scotland. And you could walk up and down a beach and not see anyone for hours.
Oh, wow.
So I found this author, Peter May, and he wrote a trilogy called the Lewis Trilogy. And this trilogy of books, they're kind of murder mystery books. Each of these three books is an independent story, but they're all connected with some of the same characters. But they take place on the Isle of Lewis, which is one of these islands in the Outer Hebrides. And I love reading these books because they're good mystery books, but it also sort of takes me back to those walks and quiet times of reflection that we had, because his descriptions of the scenery and the landscapes of the west of Scotland are really just beautiful. So if you want a true escape book, I would recommend Peter May and the Lewis Trilogy.
Well, these sound phenomenal. I will put them out on our reading list on our website for our listeners to find, Ready Player One and the Lewis Trilogy. So thanks so much for sharing what is on your book list. And we kind of touched on, in this response, some of the opportunities that you've had to travel. You mentioned this 1-year sabbatical in Scotland. It sounds like a phenomenal opportunity. And I think scientists get a lot of these great opportunities to see different places in the world. So Marcie, do you have a favorite place that you've traveled to for your work?
I do. When I was setting up my sabbatical, I joked with my husband that I was going to find a collaboration in Italy if it was the last thing I did, because I had been to the Tuscany region earlier in my career for a conference and just thought it was beautiful. And the Italian researchers, again, they sort of have this mentality of work hard and play hard, which I think suited me. And I joked that I would measure success of my sabbatical if I came away with an Italian collaboration to have an excuse to travel there. So it was kind of nearing the end of our year. I had an invitation to go down to visit 2 different research groups, one at the University of Siena and one at the University of Pisa. And I was setting up this week-long trip, and I was talking to my family about it. And I look at my kids and I was like, do you guys want to go with me? I knew these researchers and I knew the area and that these were kind of easy towns to travel in, and they would get to travel by train and see the Duomo and see the Leaning Tower. And we were fortunate to be at an international school that really promoted opportunities. Take advantage of your time being abroad and go see and take your kids on these experiences. So I talked to the school. They said, no problem. Just make sure they write a report on what their experiences are. I left my husband behind in Scotland, and myself and my two boys, we flew down to Florence and we took the train to Siena and we dragged our suitcases down the cobble streets. And I remember taking them to the research lab. On this trip, we would do 1 day of work and then 1 day of tourism at each university. So on the day of work, they packed up their backpacks, but I would find them in the lab talking to grad students about their projects. They were 9 at the time.
Wow.
And brainstorming ideas. And then we'd go out to dinner and I had these fantastic drawings of the research projects and robots that they'd seen in the labs and their own ideas of like new applications for them. And it was a really fun way to share my work with my kids, but also still have a productive engagement as well. And then on our off time, we did get to tour. And I don't know if you've ever been to Siena, but they're known for these horse races through the main plaza.
Okay.
In the Piazza del Campo, there's this beautiful tower and this moon-shaped or sun-shaped plaza with all these little cafes and this big open space. And I was telling them about how they have these horse races, and I'm sitting with some colleagues having aperitivo that they have in the afternoon. And the next thing I know, my children are giving each other piggyback rides running around this plaza. And then we packed up and we went on to the University of Pisa, and they did the same thing there. They engaged with students. They learned about the projects there, and I was able to explore and build collaboration. So I am pleased to say that I have 2 new collaborators in Italy, and now I have an excuse to go back more often. But you talked earlier about sort of how do you balance? And that might have been my my pinnacle of work-life balance that week, that I got to develop these collaborations and visit these researchers and really plant the seeds that are still blooming. I'm still working with both of those groups 2 years later, and students now are exchanging and working on projects together. But I was also able to share that with my kids and let them see what excites me for my research.
Definitely. And it sounds like your kids might have been able to put together the best report their teacher had ever seen after all those amazing.
I think it was not bad. Yeah.
Yeah. Well, phenomenal story, Marcie. Thanks so much for sharing it with us. I've never been to Italy, but now I feel like I really have to go. So
I would highly recommend it.
You've convinced me. And we've talked a little bit about the collaborative nature of your work before, and I'm glad you were able to find these 2 collaborators in Italy. And I think the people that you meet and get to work with in science are phenomenal. And this is something I really like to tout on our program, because I think the stereotypes that people have, or the vision of a scientist or an engineer that someone has in their mind when you say the word, isn't necessarily true to life. So do you have a story of maybe some of the traditions or the funny or quirky things that you've done with other scientists or engineers that really showcase this human side of science and dispel some of these myths about what it's like?
I've had fun interactions, all kinds of places. Sneaking away from a conference with 2 other friends to go explore a city that we haven't seen before, playing hooky for the day. I probably shouldn't have that be aired over the radio. Oh, we were in Daejeon, Korea, where they're known for hot springs. And one night after a day of scientific talks, a group of us just went out, took off our shoes, rolled up our pants, and stuck our feet in these hot springs that are like right on the city street. In my own lab, we try and do gift exchanges at the holidays where you pick funny gifts and exchange them. Or I tell my students, if you're going to travel to a conference, make sure you make enough time to see what's there, not just the science, but also the environment, and network with others. Because the folks that I met when I was a student, folks I met the early years that I was going to conferences, that's who I connect with now. As a researcher, I'm at my own university, and I'm kind of the only one who does what I do, but yet there's this whole network of people who do work like me at all these other institutions. And that's what makes going to conferences and scientific meetings really fun, because now you're sort of in the mix with all the like-minded people who are passionate about the same sort of research questions that you're passionate about. So you can share that passion for the science, but it turns out that you can also share a passion for good food and good memories that you make together.
Well, I'm so glad you made a lot of these points about how global science and engineering are as endeavors. You do make these connections with people, and oftentimes these friendships last for many years to come. So I think that is wonderful. And I'm glad to hear that your lab does fun stuff too. I think the gift exchanges and kind of getting people outside of their normal role of just working together in the lab is important.
Definitely.
Certainly. So we talked about some of the big questions that your lab is answering, Marcie, and some of the amazing work that you're doing in the world of robotics. But I'm curious because I know every scientist and every engineer is limited to some extent by things like funding and staff and technology and the feasibility of the work that you're doing. So if we took away all of the constraints, what is the one question you would want to tackle or the one problem that you would want to solve first?
That's big and hard for me to come up with just one. So the field of haptics has been around since I started graduate school, nearly 20 years or more. And I think the challenge with haptics is that we're sort of a cool technology looking for the right application, which is the worst thing you want as an engineer. You don't want to be designing a widget with no problem for the widget to solve.
Right.
So we as a community, we've been exploring different areas, and there's been huge advances in haptics on touch screens, which takes a special kind of actuation technology and either electrostatic or vibrations of the screen to make you feel different textures. Imagine if as you're swiping on your phone, you could actually feel the buttons or feel the interactions. But for myself, with wearable haptics, the challenge has really been, how do you take advantage of this sense that we have, the sense of touch, which can be received all over the body? We have skin, we have sensory receptors in our skin, and we have many different kinds of touch sensations. So you can imagine haptics involves sort of, as I pick up my mug of coffee this morning, the weight of the mug that I can feel, but also the texture of the mug, the temperature of the mug itself. If I get a notification on my phone, I can feel vibration. We have a sense of our position and orientation of our limbs around us. So touch is really complicated because it also requires an interaction. If you think about vision or hearing, that sense is sort of one directional. We open our eyes and we see the environment around us, or we hear the birds chirping or the cues from our messages in the background. But with touch, you can have passive touch, like I can apply sensations to an individual, or a person can reach out and explore their environment. And I think the really big challenges are, how do we recreate that artificially? So maybe it can be done invasively, where you could stimulate nerves and you could sort of recreate these exact sensations. And there's great research being done in those directions. But I just think about, how do we artificially do this with wearable technology when touch is such a complicated sensation? So if there was like no limits of funding and I could get all the best people to pursue this, I think it would be really an in-depth investigation into how best to design wearable devices to convey touch cues and how to make those cues salient and information rich and useful, whether it be for guidance and navigation or communicating with others, or maybe even just getting our Google Maps navigator to tell us when we're driving which direction we need to turn. Touch is a really complicated sense, and we're just at the very beginning of what the potential for haptics is.
Absolutely. Well, Marcie, thanks so much for dreaming big with us today and sort of bringing up some of these limitations and maybe problems, if you will, that you're facing in your field right now, and just thinking about where it could go in the future. I think this is one of my favorite questions to ask people, to kind of see where their mind's at and what the frontiers are of the field.
Yeah, you got me thinking as well.
Yeah. Well, it's great to hear about some of the big questions that you hope to answer in the future. And I think in thinking about your career, it's wonderful to reflect back on some of the people who've helped you get to where you are today and who are great sources of advice along the way. So Marcie, is there one piece of advice that you received at some point that really helped you that you want to pass on to our listeners today?
Maybe I alluded to it earlier, but I think it's persistence. Great scientists who don't persist don't make it. Maybe pretty good scientists who persist really have good findings. So if you believe that your idea is a good one, keep at it. You'll convince others, or you'll do good science proving yourself wrong. Persistence really is key. I hate to say you learn from failure, but it's not failure, it's just another experiment and more data points that help inform our understanding of the world and how things work.
Absolutely. And I think you have to persist because science and engineering is, in a lot of times, a long time scale. So you might not have the answer right away, but you're absolutely right. Through going through these iterations, you might get to it eventually.
That's right.
Well, wonderful advice to pass on to our listeners. Is there any other piece of advice you want to share, or a last note of inspiration you want to leave them with today?
I think you just need to make sure you're doing things that make you happy. If I wasn't truly excited about the potential for haptic feedback or wearable robotics, it would be tough to go to work every day. So find something that you're passionate about and persist.
Well said, Marcie. Can you tell our listeners, if they want to learn more about you and the wonderful work that you do, where should they go?
Well, we have a great website for our lab, and it's the mahilab.rice.edu. And that's mahi like the fish, but also mechatronics and haptic interfaces. And there's a great way to see our current research projects, but also contact information for the lab. And my email address is also available on that website if you wanted to reach out to me.
Perfect. Well, listeners, definitely check out Marcie's lab website. So many amazing projects. We only scratched the surface today. And Marcie, thank you so much for joining us on our program and sharing a piece of your own story.
You're welcome. It's been a real pleasure.
Well, it was a delight to chat with you today. And listeners, great to have you here as well. We'll see you next time on another episode of People Behind the Science.